It's 2029 and every merchant ship in the world is fertilizing the ocean with iron, a last-ditch effort to draw carbon dioxide from the air as global emissions near the point of no return. This global attempt to remove CO2 from the atmosphere has been 11 years in the making, since 2018, when the IPCC Global Warming of 1.5C special report warned that emissions reductions alone would not be enough to restrict global heating to 1.5 degrees Celsius. Removing carbon dioxide from the atmosphere would also be required. Key points. Carbon dioxide removal techniques will be required to restrict global heating to 1.5 degrees Celsius. According to the 2018 IPCC report, a UN expert group has reviewed potential marine geoengineering techniques to remove carbon dioxide from the atmosphere. Carbon removal at a global scale needs to be in effect within 10 years, experts said. The hope is that the powdered iron will trigger a bloom of phytoplankton that will remove a gigaton of CO2 from the atmosphere, by taking the carbon to the ocean floor when they die. There's evidence to support the concept. Iron-stimulated blooms have been observed in nature for some time, sparked by events such as the 2010 eruption of the Icelandic volcano Eyjafjallajökull, and Saharan desert dust plumes. In 2029, it's just one of a number of ideas about to be employed across the planet to remove atmospheric carbon dioxide. Share. A recent working group reviewed a wide range of proposed marine geoengineering techniques. Supplied, GESAMP. How best to remove CO2. Back in the present, and as signs of global warming continue to mount, a push is on to find ways to draw CO2 from the atmosphere. It's now abundantly clear from the IPCC 1.5C special report that if we're going to restrict warming to 2 degrees or less, then mitigation of the reduction of emissions on its own is not enough, said Philip Boyd, professor of marine biogeochemistry at the University of Tasmania. We have to go beyond that, and we now have to intervene in the climate. Professor Boyd recently co-chaired a working group for the UN Advisory Organization, group of experts on the scientific aspects of marine environmental protection, GESAMP, that reviewed 27 potential marine geoengineering techniques that had been studied or modeled to varying degrees worldwide. The group particularly focused on iron fertilization across 10% of the Earth's oceans by utilizing every merchant ship in the world, adding lime to 10% of the oceans to enhance alkalinity, increase CO2 uptake and counter seawater acidity, drawing up cool, nutrient-rich water from the depths with large pipes to create an artificial upwelling that provokes algal blooms while also cooling the ocean's surface, injecting liquefied CO2 into the seabed in depressions and trenches where it can be stored for 1,000 years, increasing the ocean's reflectivity by drawing up cold water to increase Arctic ice thickness, or by adding foams, microbubbles or reflective particles to the surface, brightening marine clouds by spraying fine seawater into low-lying stratocumulus clouds to increase their reflectivity and reduce surface temperatures, farming seaweed on a large scale before entombing it deep in the ocean to sequester its carbon, or process it for biofuels. In short, the group found a lot of potential. But more research, modeling and pilot programs are required, especially in consideration of the massive scales required. What we are trying to do now is put some incentives out there, create some of these models for feedback, Professor Boyd said. But right now I can't see any one of them sticking out head and shoulders above the rest. Share. Saharan dust storms over the Atlantic Ocean fertilize oceans with iron minerals. Supplied, NASA. Old concepts and natural evidence. The concept of using reflective particles to reduce warming was floated as early as 1965, when scientific advisors to U.S. President Lyndon Johnson recognized that increased CO2 in the atmosphere could bring about climatic change. They raised the prospect of spreading small reflective particles over large oceanic areas in an effort to reduce warming and inhibit hurricane formation. They raise the prospect of spreading small reflective particles over large oceanic areas in an effort to reduce warming and inhibit hurricane formation. More recently, scientists have investigated spraying fine seawater into low-lying stratocumulus clouds above the Great Barrier Reef to make them brighter and reflect more sunlight. The hope is that this will keep the water temperature low enough to prevent coral bleaching. Scientists internationally have also been modeling a strategy to inject aerosols high into the stratosphere to replicate outcomes from the 1991 Mount Pinatubo eruption, in which reflective sulfuric acid droplets drew down average global temperatures by 0.5 C. Sci teaser. A planet-sized sunshade. Should we try and turn the stratosphere into a giant global sunshade to stop Earth from overheating? But Andrew Lenton, an ocean carbon cycle modeler with the CSIRO, said geoengineering of this kind could have transnational consequences. You're changing the balance, changing precipitation, and there is some really significant side effects that can go here, he said. Dr. Lenton also pointed out that such techniques would not remove CO2 from the atmosphere, which in high levels reduce pH levels at the oceans. Dr. Lenton also pointed out that such techniques would not remove CO2 from the atmosphere, which in high levels reduced pH levels at the ocean's surface and created acidity. It might be like kids in a candy store with all these options available to us, he said. But when you start to dig a bit deeper, everything has risk or potential challenges associated with it. IPCC CO2 budget and geoengineering teaser humanity's CO2 budget. The IPCC in 2018 warned humanity could only emit another 420 gigatons if it is to have a 66% chance of limiting global heating to 1.5 degrees Celsius. Uncertainties exist due to transient climate responses to high emissions, such as changes in the Earth's radiation absorption, thawing permafrost and wetlands releasing methane. The IPCC added that all analyzed pathways included a degree of carbon dioxide removal to neutralize emissions from sources where no mitigation measures had been identified, looking for ideas with multiple benefits. Professor Boyd said there was a preference internationally for techniques that had multiple benefits for the environment, along with those that did not step too far from the realms of financial reality. There has been so much sensationalism around this, with people talking about mirrors in space, or thousands of these bobbing pipes in the ocean, he said. It's become a little bit sci-fi. We really want to bring that back to Earth by exploring work that involves environmental co-benefits. Share. Scientists have been studying the effects of acidification on reefs. Supplied, Aaron Takeo Ninokawa. This included the concept of regenerative agriculture, which could see mined minerals with high CO2 absorption qualities worked into farmland as fertilizer. It comes at a low cost. You're sequestering carbon, you're fertilizing, and you're also boosting the soil profile, Professor Boyd said. It might also be possible that you could further till that soil to build up its profile for biochar. Biochar is a carbon-rich material like charcoal that is produced from biomass through slow pyrolysis rather than incineration, that is, heating in the absence of oxygen rather than burning. Food and agricultural waste and even manure can be turned into biochar and added to soil, where it sequesters carbon and helps retain soil moisture and nutrients, subsequently bolstering crops when matched with the right varieties and conditions. Share. Biochar, such as this collection created from bamboo, can also help retain soil moisture. ABC Sunshine Coast, Jacqueline Street. Just 10 years to work it out. Trees also capture and store carbon dioxide, for as long as they stay alive, at least, and their planting in recent decades has been touted by commercial entities who claim to be carbon neutral as a result. Dr. Lenton cited a colleague who modeled growing trees on every available piece of land worldwide under high-emission models. But she was not even able to get to a medium scenario of global emissions by basically removing all the agricultural land and turning that into forest, he said. The reality is, the scale is incredible, and there is competition for land. You can't turn all sub-Saharan Africa into a forest and think the people there are going to be happy with that. Share. Water availability could stymie plans to plant billions of trees to capture carbon. ABC Rural, Kim Honan. Research published earlier this year, however, estimated there was enough suitable unused land on Earth for reforestation to store about 205 gigatons of carbon. We can't just look at these things in isolation, Dr. Lenton said. We may potentially be able to plant a huge amount of forests, but planting eucalyptus, for example, requires a huge amount of water. He believes humanity has only 10 years to have large-scale carbon dioxide reduction schemes up and running. These schemes would need to be making a significant dent in carbon dioxide levels, as by that point CO2 emissions will likely have reached the limit required to keep global warming to 1.5 degrees Celsius. But that, Dr. Lenton said, was the root problem, one that casts a shadow over everything scientists were potentially fast-tracking to draw carbon from the sky. If emissions are not going to be falling globally, is this something even worth doing?